Hello everyone, welcome back to my channel. Now we are going to start off with the course on MCQs on electrical machines. Starting off with question. Total core loss is also called as, so it is also known as magnetic loss, as we know that the iron loss is proportional to flux density or flux. It is also called as magnetic loss. And the total core loss or magnetic loss consists of eddy current as well as hysteresis loss. So it is also known as magnetic loss. Which of the following are variable losses? So the answer is armature copper loss is a variable loss. As we know, it is directly proportional to square of armature current. Therefore, the load varies, so it will also vary. Next. Maximum efficiency will occur when the copper loss is. So the answer is when it is equal to the iron loss. So condition of maximum efficiency is when the copper loss is equal to iron loss. Next. Swinburne test is conducted under which of the following condition? So the answer is it is no load condition. We know that it is conducted under the no load condition to find the no load loss or the constant loss. So this can't be done in the DC series machine. Next. Hopkins test is conducted under which of the following condition? So the answer is it is conducted under the full load condition. It is also known as back-to-back test or regenerative test. It requires two identical DC, shunt or compound machines. One acts as a motor and other acts as a generator, and both are coupled mechanically as well as electrically. Next. The current drawn by 230 volt DC motor of armature resistance 0.5 ohms and back EMF 200 volt is IA is equal to VT minus EB by RA. So we can just write the values 230 minus 200 divided by 0.5. So the answer will be 60 amperes. So the answer is 60 amperes. Next. Which of the following methods are used to control the speed of the DC motor? So the answer is the field current control, armature circuit resistance control and supply voltage control. All of the above can be used. So the answer is it is D. Next. DC series motor is accidentally connected to a single phase AC supply voltage. So what will happen to the torque produced? So the answer will be it will be pulsating and unidirectional. As we know that in DC series motor, the AC current through the field and the armature winding will be unidirectional by the commutator and the brushes. So the torque will be unidirectional, but it will be pulsating in nature. What is the increase in torque expressed as percentage of initial torque? If the current drawn by this DC series motor is increased from 10 amperes to 11 amperes. So we know that torque is directly proportional to I square. Percentage increase in the torque is 121 minus 100 by 100 into 100%. So that will give us 21%. So the answer is it is B. Next. A flat compound generator is obtained from a compound generator by connecting a variable resistor in parallel with series field. So the answer is it is B. We know that the variable resistors in parallel with the series winding is called a diverter. A flat compound generator has a constant terminal voltage characteristics. Next, in a DC motor under constant terminal voltage, what is the relationship between the torque and the power? So the torque is directly proportional to the power. So answer is A. Next, slot wedges in a DC machine is made up of, so the answer is it is made up of silicon steel. We know that it is used to reduce the air gap flux to reduce the armature reaction. So they are made of silicon steel. Next, for p-pole machine, relation between the electrical degrees and mechanical degrees is, so the answer is it is theta electrical is equal to P by 2 into theta mechanical. So one mechanical rotation covers P by 2 electrical cycles. Next, the air gap between the yoke and the armature is DC machine is kept very small. So the answer is it is to achieve a stronger magnetic field. We know that the magnetic field is created by the field poles. The gap between the yoke and the armature is kept small in rotating machines. Next, a 4-pole generator is running at 1500 rpm. The frequency of current in the armature winding is, so the answer is it is A, that is 50 hertz. How? We know that N is equal to 120 F by P. So we can write F is equal to N into P by 120. So just putting up the values from the above question. So the answer will be 50 hertz. Next, a triangular MMF wave is produced in the air gap of an electrical machine. Such wave is produced by, so the answer is it is rotor of a DC machine. In DC machine, the armature winding is placed in the rotor and it has a triangular MMF wave. Next, which of the following motor has a negative speed regulation? So the answer is it is differential compound motor. In this motor, the series flux opposes the shunt field flux. As the load increases, the flux will also increase for the differential compound motors. Therefore, the speed will increase and the speed regulation will be negative. Next, a commutator in a DC machine provide which rectification? So the answer it provides a full wave rectification. We know that it converts AC voltage into DC voltage. Next, in DC machine, armature winding are placed on the rotor because of the necessity for commutation. So the armature winding of a DC machine is placed on the rotor to facilitate the commutation. Next, dynamic braking can be used for. So the answer is it is used for all of the above: 2-point starter, 4-point starter, or 3-point starter.
Okay, so if you like my videos, you can also subscribe to my channel. And if you have any doubt, you can always ask me in the comment section below. Thank you.